All right, last problem of this learning guide. I'm getting so tired, it's about time for me to go to sleep. An object is launched from the ground with an unknown initial velocity. Okay. If the object reaches a maximum height of 256, what velocity must it have been launched with? Well, we need a quadratic model here. H of t equals negative 16 t squared plus v naught t plus nothing because it's launched from the ground. Okay, so there's our height function. And let's take the derivative and find our velocity function, v of t. So the velocity function, aka the derivative of the height function, is going to be negative 32 t plus v naught. And so we know that at whatever time the object reaches its maximum height, at that same time the velocity is zero, which means we can solve the system of equations. 256 equals negative 16t squared plus v naught t, right? This is representing the object when it's at its maximum height. So t is whatever time it takes for the object to get to its maximum height. We know that the velocity is zero, so 0 equals negative 32t plus v naught. And so 32t equals v naught, and we can substitute into this equation. 256 equals negative 16t squared plus v naught is 32t. T times t is t squared. So 256 equals negative 16t squared. Not what I meant to write. Negative 16t squared plus 32t squared leaves a positive 16t squared. This equation divides 16 on both sides, so you get 16 equals t squared, and so t equals 4. Just the positive, because it wouldn't make sense for t to equal negative 4. So we know t is 4, so we can find our initial velocity using 32 times t equals v naught, right there. So 32 times 4 equals v naught. Okay, 32 times 4. Let's do it. Well, that's 32 times 2 times 2. 32 times 2 is 64. 64 times 2 is 128 velocity meters per second. Good night.